Okay, so number 6, we want to describe the solid of revolution. So tell me what shape you see if we spin this flat thing around this line. So for this, I like to picture if you had a pencil in your hand and for some reason you decided to tape a rectangle to the side of your straw or pencil or whatever you're holding. And then you take your pencil between your two hands and you rub it like you're trying to light a fire or something like that. So you're spinning the pencil, you're spinning the straw, which means the little flag that you tape to the side is also spinning. So the rectangle doesn't always stay on the left side. It's going to flip behind the straw and in front of the straw, and behind the straw, in front of the straw, or pencil, or whatever I made it you imagine. So you're going to sometimes see the rectangle over on the right. Sometimes it'll be in front, sometimes it'll be in back. But what you'll end up seeing, which is hard for me to draw without showing it to you, is you'd end up kind of looking at a cylinder. The other one is pretty similar, but it's a little different because it's not just a simple rectangle. Now the rectangular part will carve out a cylinder. That's not wrong. But the top part is the weird thing, because you taped a triangle to this thing. So we got this triangle flipped in. So yeah, it's still going to go behind and it's going to go in front. I shouldn't have colored that in. So it's going to go behind, it's going to go in front, but sometimes it'll do big circles, and sometimes it'll do teeny little circles, which means on top, you have a cone shape. While on bottom, you are still getting that rectangular shape getting spun around. You still get a cylinder. So sometimes you get two shapes kind of glued together. Sometimes you only get the one. So that's kind of what we're getting into here. We're starting with a rectangle and it's being rotated around whatever line it says. And I want to know what shape it is and what the volume of that shape would be. So this is really similar to number 6 here, where I have a rectangle that's being rotated. So here, rectangle being rotated, but this time the line about which we are rotating is horizontal to start out with. So this rectangle starts out above, but sometimes it'll start going and it'll be below by 2 units and it'll go back up. This end will go below by 2 units and go back up. So sometimes there's a rectangle completely on the bottom, and sometimes you still have the rectangle completely on the top. But what you end up with is the shape of a cylinder. Anytime you revolve a rectangle, you're making a cylinder. So we're going to go back to our formula. Pi r squared times the height. So it says volume in terms of pi, so I don't need to worry about getting the decimal answer here. I do need my radius. That's the distance from the middle of the circle, so that would be on the x-axis, to the edge of the circle. We can see that's 2 squares, so 2 units. Then we have to multiply that by the height. We said the height was the distance from one end circle to the other end circle. So picture I knocked the soup can over, but it's still the distance from one of the metal circles to the other metal circle. So if I count those squares, there would be 1, 2, 3, 4 squares. So 4 units is the height. So pi times r squared. If I combine all my numbers, I'm going to be multiplying 4 times 4, which means I'll have pi times 16, so our volume is 16 pi. There's no units, so I could just say cubic units. Part B is basically the same question, but we're changing the line that we're rotating about. Now it says y equals 2. If you remember back to your algebra days, which I'm sure you're thinking about a lot over summer vacation, that's a horizontal line. So it still touches this rectangle like this one, but instead of starting out above the line, we start out below the line. So you're still going to spin it above and below, so you can think of sometimes the rectangle is completely above the line, sometimes it's completely below the line, but we still get the cylinder. So my formula for the cylinder is still pi r squared h. I'm too lazy to write that twice. The distance from the center of the circle, that's not my pencil, center of the circle to the edge of the circle is still my radius, which is still 2. We want the distance between the circles for the height. So from one circle to the far circle, still 4 units, which means if you look at the problem we just wrote out, it's the exact same thing. I missed that. Let me try again. So technically a different cylinder, but the dimensions are the same. I can't spell. So we still get the same volume. If I made you flip around the x-axis, you'd get a y-axis. You'd get a different line altogether. But this is the same cylinder. They look the same. That looks the same as that thing. It's just where they were drawn on the coordinate grid. So pi r squared h is the main thing you need to know. Pay attention to what the radius is and what the distance between the circles.